Alrighty. I hope you all are doing well today. Let's take a look at a few concepts from section 5.2. So this concept, the power rules with positive exponents and multivariate products. So you may want to pause the video here and write that topic down. Okay, so let's take a look at this. We see that we have 3, and that's a z in there, 3z times x squared, all raised to the fourth power. So we don't have anything inside the parentheses that we can simplify, but outside of the parentheses there, we have it all being raised to the fourth power. So what we need to do is to raise each one of those, each term inside to the fourth power there. And then simplify. So to simplify this, I'm going to come down here. To simplify this 3 to the fourth power, again, that would be 3 times 3 times 3 times 3, which is 81. And then z to the first raised to the fourth power would be z to the fourth power. So what we have here is what we call our power to a power rule. And when we have an exponent base with an exponent inside the parentheses raised to another power outside of the parentheses, the shortcut to doing that, to simplifying that, is to multiply those exponents. So let's take a look and see what that really means. So if we're just looking at the x squared to the fourth power, remember that exponent outside tells us how many times we're multiplying this base times itself. So what that means is x squared times x squared times x squared times x squared. And we learned before when we're multiplying like bases that we could add the exponents, so 2 plus 2 plus 2 plus 2, that gives us x to the eighth. So that's how we got that x to the eighth. But again, the shortcut to that is that when you have uh, base with an exponent inside the parentheses raised to another power directly outside of the parentheses, then you multiply the exponents. Okay, so let's take a look at another one. So again, you may want to pause the video here to write the problem down. All right, so we want to raise everything to the second power. So we have negative 6 raised to the second power, b to the fourth raised to the second power, and a square raised to the second power. So negative 6 raised to the second power, since that negative is inside the parentheses, remember that means that my base is negative 6. So negative 6 times negative 6 is positive 36. And then b to the fourth raised to the second power. Again, we have that power to a power, so the easy way to simplify that is to multiply the exponents. And then the same thing here, we have an exponent inside, exponent outside, power to a power, multiply the exponents. So you see we have 36 b to the eighth, a to the fourth. All right, so those are two examples for the power rules with positive exponents and multivariate products. All right. So this next concept is power rules with positive exponents and multivariate quotients. So quotients means that we have a fraction here. So again, you may want to pause the video here and write the problem down, the concept name and the problem. Okay. So same idea here. We want to raise everything to the fourth power in the numerator and denominator. So, and the first thing I always do is to check to see if I can simplify anything inside the parentheses before I work with that exponent outside the parentheses. So now we have negative 2 to the fourth power, v to the fourth power raised to the fourth power. And then in my denominator, we have u raised to the fourth power. So everything gets raised to that exponent that's outside of the parentheses. All right. right, so negative 2 to the fourth power, negative 2 times negative 2 times negative 2 times negative 2, positive 16. And then v to the fourth raised to the fourth power, power to power, multiply the exponents, v to the 16th, all over u to the fourth. All right, so we have positive exponents. We don't have anything that we can simplify. That is the final answer for that one. Okay. All right, so same concept. We have negative 3 y squared all over z raised to the fourth power. So we're going to raise everything to the fourth power. All right, so negative 3 raised to the fourth power. Y squared raised to the fourth power, exponent in the inside, exponent outside the parentheses, power to a power rule, so we multiply, all over z to the fourth. So 81 times y to the eighth, all over z to the fourth. All right, so the next concept, again, you may want to pause the video here and write down the concept and the problem. Power and product rules with positive exponents. All right, so the first thing that I see, there's nothing that I can simplify inside the parentheses in either one of the parentheses, but I have this exponent here, a square outside of that first parentheses, so I need to raise everything in there to the second power. Sorry about that. That should be x squared. So that's from the first parentheses. The second parentheses, I don't have anything that I can simplify. So let's do this. So we'll leave it like it is. Okay, so we want to simplify inside this brackets here. So 2 squared, 2 times 2 is 4. X to the second raised to the second, x to the fourth. Y to the third raised to the second, multiply those exponents, y to the sixth, z squared times 3xy squared. Now, this is all multiplication, so at this point we can rearrange and regroup using the associative and commutative properties. So 4 times 3, x to the fourth times x to the first, and y to the sixth, we really don't need a dot there, y to the sixth times y squared, and then z squared. So I'll make sure I use everything. 4 times 3, x to the fourth times x to the first, y to the sixth times y squared, and then z squared. And then at last we simplify. So 12 x to the fifth. So when we multiply like bases, we add the exponents, remember. So keep that in mind. So that's understood to be x to the first. Same thing here. When we multiply like bases, y to the sixth and y squared, we were trying to see how many times the y is being multiplied times itself, which in this case would be 8, and then z squared. Okay, let's look at another problem similar to that one. All right, so we have negative 1x squared. So negative 1 to the fourth x squared to the fourth, y to the third raised to the fourth power. And remember, the negative 1 comes from, this is an understood negative 1 right here in front of that x squared. And then over here, we'll raise everything to the third power. All right, then simplify. So negative 1 to the fourth is positive 1. So that just becomes positive 1, understood. X squared to the fourth, x to the eighth, y to the third to the fourth, y to the 12th. Second parentheses, 3 to the third, 27. X to the ninth, y to the sixth, z to the 12th. And then we want to finish simplifying that, and you can rearrange these again, or you can just go ahead and add the exponents of the like variables. So 27 is our coefficient, x to the 8th, x to the ninth makes x to the 17th. Y to the 12th times y to the 6th makes y to the 18th, because we add those exponents. And then z to the 12th. All right, and then the final concept that we'll cover in this video is the power rule and quotient rules, power and quotient rules with positive exponents. So again, same concept, except we have a fraction here. Now, since I have the exponents outside the parentheses in the numerator and denominator, I cannot simplify before I simplify the fraction itself before I simplify the power to the power rules. So the first thing that we have to do is to, in the numerator, raise everything to the second power. In my denominator, raise everything to the third power. And then simplify those exponents. So 2 squared is 4. Y to the fifth raised to the second is y to the 10th. 4 to the third. Y to the second raised to the third. And then after I take care of my exponents that are outside the parentheses like that, now I want to see if I can simplify the fraction. So 4 over 64, I know I can simplify that because it has a common factor of 4. 4 goes into 4 one time, 4 goes into 64 16 times. So I have 16 in my denominator here. I understood 1 in my numerator. And then for my variables, they're both y. Sorry about that. But I have more y's in my numerator than I do my denominator. So using my quotient rule, I'm going to subtract 6 from the numerator and gives me y to the fourth in my numerator. So I'm left with positive exponents, everything is simplified, and we're good. Alrighty, let's try one more problem. Okay, so again, power and quotient rule, same concept. All right, so in the numerator, we'll raise everything to the fourth power. In my denominator, we raise everything to the second power. All right, so in the numerator, we have 2 to the fourth, which is 16. A to the fifth raised to the fourth, which is a to the 20th. 8 square in my denominator, 8 times 8. And then a square raised to the second, multiply the exponents, a to the fourth. And then after you simplify those exponents, then you want to make sure that you simplify the fraction itself. For example, 16 and 64 have a common factor of 16. So I can simplify that to 1 over 4. And then when I look at the a's, I have a to the 20th and a to the 4th. So I have more a's in my numerator. So I'm going to subtract the 4 from that 20, and that leaves me with a to the 16th in my numerator. And that's a wrap for today. I hope you found this video to be helpful, and thank you and see you later.